Let's talk hyperbolas. You've probably seen the graph of a hyperbola before, although you might not have called it by that name. The graph of the function y equals 1 over x, the reciprocal function, has the shape of a hyperbola, and that's the one that goes like this. We have two separate pieces, one in quadrant 1, one in quadrant 3, a couple of asymptotes, and that's actually a hyperbola. So all of the hyperbolas that we see are going to look like some version of that. Looking at the equations here, they might at first strike you like they're a whole lot like the equation of an ellipse, and they are, with one really big important difference, and that's right here. In an ellipse, my two terms are added. In a hyperbola, they're subtracted, so I have a positive term and a negative term. And that is going to tell us something fairly important about the hyperbola, which is which way it opens. When the x term is positive, my hyperbola is going to open in the x direction, so on the x-axis or parallel to the x-axis. And that would be left and right. And that is left and right, since it has two pieces. One opens left, one opens right. When the y term is the positive one, my hyperbola is going to open along the y-axis or parallel to the right y-axis, so that'll be up and down. Other parts of a hyperbola, you might recognize HK, same as in an ellipse, same as in a circle, and we'll call it the same thing. HK is the center of the ellipse. Now we're going to talk A and B and see what they tell us. So there's my center, HK. A is actually going to do the same thing that it did in an ellipse. A is the distance from the center to the vertices. There's two of them. And they're each A away from the center. So I'm going to go a distance of A to either side of the center and find a vertex. If we imagine drawing a line through the two vertices in the center, and then imagine a line perpendicular to that, we're going to go a distance of B on that perpendicular line to get our next 2 points. So B is going to tell us the distance we go perpendicular to the line connecting the vertices. So I'm going to go B, and B might be more than A, might be less than A. Who knows? It just depends on the hyperbola. So distance there is B. We don't have standard names for these points. Different books call them different things. We're just going to call them points that are a distance of B away from the center. We know that a hyperbola has a couple of asymptotes. Here's an efficient way to locate the asymptotes. I'm going to draw a box through the two vertices and the 2 points that are B away in the perpendicular direction. And by box, I do mean very literally a rectangle. Not any kind of fancy box, just a rectangle. And then my asymptotes are going to go through the corners of the box and through the center. There's one through the corners of the box and through the center, through the opposite corners, I should say. There we go. The only 2 points that are actually on the hyperbola that we have so far are the vertices. All the rest of this is framework, but this framework is really enough to draw the graph. My graph is going to go through the vertex and along the asymptote. So this is kind of a wide opening hyperbola here. They come in different shapes and sizes, same as ellipses. So there's my graph. We haven't talked about foci yet. Certainly a hyperbola has those. It has two of them, and they'll be to the inside of its two parts. We'll call the distance from the center to a focus C. And again, that's consistent with what we called it for an ellipse. From the center to the focus is C. We're going to notice A and B are perpendicular to each other, and we might suspect some kind of Pythagorean relationship here, and there is one. So here's A. A and B are perpendicular. If I took the distance C and put one end on a vertex, the other end would land on this point. That's a distance of B away from the center. So A and B form the legs of our right triangle. C is its hypotenuse. Our Pythagorean relationship for a hyperbola is C squared equals A squared plus B squared. So if you have the equation and you know A and B, you can find C and find the foci.